Hello, thanks for clicking. Welcome to another Calculus 2 production. Today we're going to do more with integration by parts. There's actually a bunch of things that we can do with this. We can make them a little more difficult. We can add bounds to them. So let's take a look at some more problems that we can work with, and we'll see what else we can bring with integration by parts. Okay, so let's first start with a function here. We want to integrate arctangent of x, with respect to x. Okay, remember our parts formula. We have the integral of u dv is equal to uv minus the integral of v du. Okay, remember we're picking a u and we're picking a dv, right? And basically we're picking dv because it's the stuff that's not du, or that's not a du. All right, so I want to integrate arctan x dx. Okay, so there's really only one thing to pick. Now we're choosing u using Lipit, right? Lipit good. Logs, inverse trig, polynomials, exponentials, and trig. So inverse trig is actually second on the list. So the only thing we can pick for u, though, is arctan x. So we're going to pick that. dv will be dx. That's the only thing that's left. So we're going to derive u. The derivative of u, derivative of arctan x is 1 over 1 plus x squared dx. And then we're going to integrate dv. The integral of dv is v, and the integral of dx is x. Okay, all right, so then let's go from here. So the integral of arctan x dx is uv. So that's x arctan x minus the integral of v, which is x, du. So that's going to be x over 1 plus x squared dx. So now, again, the next integral should be easier than the one before it. Well, the one before it, we literally couldn't do that. We had to use parts to do it. There's nothing else we can do. But this next one, this is much easier. This problem is possible. We can use substitution to do it, right? So if we let w be 1 plus x squared, dw is 2x dx. You need a 1/2 here, though, for Beach Boys. So this is going to be x arctan x minus 1/2 the integral of dw over w. But the integral of dw over w, let's just rewrite all this, is natural log absolute value w plus c. But w is equal to 1 plus x squared. So I'm not even going to put the absolute value. I don't need it, right? 1 plus x squared is always going to be a positive. And there's my answer. Okay, so you can use parts on integrals that aren't actually products. So in some cases, you need to use parts. Any inverse trig function that you want to integrate, arctan, arcsecant, arc sine, you name it, any one of those, if they're in the integrand by themselves, you have to use parts to do it. Okay? All right, here's another one. ln x, the integral of ln x. So again, that's all that's there. So I don't know what that is. I know the integral of 1 over x is ln x, but absolute value. But I have no idea what the integral of ln x is. Here's another one that you have to use parts. So we're going to lip it good, pick a u, and then the rest will be dv. Well, there's only one thing to pick for u, and that's ln x. So we're going to pick it. We got no choice. The integral, and then we're going to pick dv. dv is what's left over, so that's dx. We're going to derive u. The derivative of ln x is 1 over x dx. The integral of dv is v. The integral of dx is x. So now we're going to use our formula. U dv is u times v minus the integral of v du. So we're going to have uv x ln x minus the integral of v, which is x du times 1 over x dx. But x times 1 over x, well, that's just 1. So this is just the integral of dx. The integral of dx is x. So that's x plus c. So the integral of ln x with respect to x is x ln x minus x plus c. Now, for some reason, this rule is actually fairly easy for people to remember. I'm not sure why, but it is for the most part. So some people just choose to memorize it off the top of their head. All right. But again, if you didn't memorize it, you could use parts to do it. You just have to know, hey, I have to use parts to do this. It's not something that I can just integrate by looking at it. Okay. All right. So let's go for something else. Let's try the integral of x squared sine 4x, a little more complicated. So now we're going to use parts again. Now I have two things that are multiplied. Forgot the dx there again. We have x squared times sine 4x dx. So we're going to lip it again, lip it good. We have a couple choices here for u and use parts on it. U can either be the x squared or the sine 4x. We're going to choose the polynomial, so u will be x squared, dv will be sine 4x dx. So we're going to derive u. The derivative of u is 2x dx, and then we're going to integrate dv. The integral of dv is v. The integral of sine 4x, I need substitution to do that, or you just have to do the substitution in your head. 4 dx, need a 1/4 for Beach Boys. So this is going to be 1/4. The integral of sine is minus cosine. And then I need the 4x there again. Okay, so the integral of u dv is equal to u times v minus the integral of v du. So the integral of x squared sine 4x dx is equal to uv. So that's negative x squared over 4 cosine 4x. So I kind of cleaned that up there when I multiplied those two. Minus the integral of v. V is negative 1/4 cosine 4x. So the negative times that negative will make a positive. I'm going to keep the 1/4 out of there and write cosine 4x du. Du is 2x. So I'm going to multiply this 1/4 by 2 and put this x up here in the front. So now, if you look inside the integrand, I have the integral of x cosine 4x dx. And now you might be saying to yourself, well, wait a minute. The next integral is supposed to be something that I can calculate, right? And I can't calculate this integral. And I would agree with you. But the question is it easier than the one before? And theoretically, I guess, if you look at it, you started with x squared sine 4x. Now you're down to x cosine 4x. So you've reduced the x squared by 1 power. So I guess mathematically it is easier to work with than the one before it. So we're going to try to integrate x cosine 4x dx. Now the question is, how would we do that? Well, we would use parts. So you're going to have to use parts again. So you can use parts multiple times. So I need to pick u and dv a second time. U is either x or cosine 4x. I look up at my lipit, and I'm going to pick x for u. dv will be cosine 4x dx. Okay, so du is dx. The integral of dv is v. The integral of cosine 4x, you need this substitution again, right? You're going to get a 1/4 out there. The integral of cosine is sine, and I need the 4x substituted back in. So now what we have is we have negative x squared over 4 cosine 4x plus 2 times 1/4 is 1/2. And now inside this bracket is going to be what this integral represents. This integral here that I just circled is u times v, 1/4 x sine 4x, minus the integral of v. I'm going to put that 1/4 outside, du dx. So now if I take a look at this, I'm still not done. I still have an integral to do, but this integral can now be done, right? I don't need parts to do this. I can literally integrate sine 4x. We just did it up here a minute ago, okay? We know what the integral is. So just make sure you have all your multipliers out there, your constants multipliers out there, and you be careful with your brackets and your parentheses because you're going to need them to keep track of where everything belongs. So now, the integral of sine 4x, we just happen to do it up here. It's negative 1/4 cosine 4x. So that's 1/4 there, minus 1/4. Now this integral is negative 1/4 cosine 4x. I think we'll write it like that. And now the integrals are done, so I need a plus c. And then I'm going to try to clean this up a little bit. Oops, that should be a 4. Cosine 4x. I'm going to distribute this 1/2 to both of these terms. So 1/2 times 1/4 is an 1/8 x sine 4x. And then these two negatives multiply out to make a positive. 1/4 times 1/4 is 1/16 times the 1/2 that's out there is 1/32 cosine 4x plus c. And that's the right answer. So there are problems where you use parts, where you have to use parts more than once. All right, that's something you have to be aware of, that it is possible that it could happen. Okay, finally, let's try one with bounds. We're going to integrate from 1 to 4 ln x over x squared dx. Okay, so again, we're going to use parts for this. This really is two things that are being multiplied, right? It's ln x times 1 over x squared dx. So we're going to lip it good, pick our u and our dv. So our choices are, we have a log, ln x, and that's top of the food chain. So u is going to be ln x. dv is going to be the leftover stuff, which is 1 over x squared dx, which I can rewrite as x to the minus 2 dx, right? I'm going to have to use the power rule on it. And then, so the derivative of u, du, is derivative of ln x is 1 over x dx. The integral of dv is v. The integral of x to the negative 2 is x to the negative 1 over negative 1. And I want to integrate this from 1 to 4. So the integral of u dv is uv. So we can put this down on the bottom. Let's make that negative 1 over x. So it's going to be uv. So that's negative ln x over x, uv, minus the integral of v. So I'm going to put this negative out here, v du, times another 1 over x dx. All right, so now in terms of the evaluating, we're going to evaluate this from 1 to 4. So this first integral, or this uv, has been integrated. So this is straight line from 1 to 4. This second integral is not done yet. So we have straight line from 1 to 4, negative ln x over x. These two negatives make a positive. 1 over x times 1 over x is 1 over x squared. So this is the integral of, well, this is really 1 over x squared up there, which I'm going to bring back to the top, make it x to the negative 2 again. And I'm going to integrate it. So this is straight line from 1 to 4. Negative ln x over x. The integral of x to the negative 2. I add 1 to the power, divide by what I get. And this is going to be plus straight line from 1 to 4. X to the negative 1 over negative 1. So now I'm going to evaluate this. I'm going to substitute 4 in. It's negative ln 4 over 4 minus negative ln 1 over 1. And then this negative here I'm going to put out here. So this is minus. And then I'm going to evaluate again. So the negative already went outside. The negative got put out here where this positive sign was. So now it's a subtraction. I'm going to plug in 4. I'm also going to make this 1 over x. So this is going to be 1 over 4 minus 1 over 1. Natural log of 1 is 0. So this term washes out. And I get negative natural log of 4 over 4. That negative washes out as well with 0. And this is 1/4 minus 1, so that's minus 3/4. Oops, no, it's minus negative 3/4. Right? Minus negative 3/4. That makes positive. So this is negative ln 4 over 4 plus 3/4. And that's the correct answer. Okay, so that's how we can evaluate a definite integral with parts. And that's it. As always, thanks for clicking.